سلااو کارانی عزیز لەم لەکچەر ئۆنلاینە لەکچەری ئەمڕۆ باسی نەچۆل گاز دایرێکشن دەکەین هەرچەندە لە پۆل کە دەوام هەبوو زیاتر لە نیوەمان تەواو کرد هەوڵ دەدەم بە خێرایی ڕڤژنی بۆ بکەن ڕیڤایزی بۆ بکەم ئەوجا ئەوە دەست پێ دەکەم بە تەواوکردنی ئەو چەپتەرە وەکو لەلاتان ڕوون و ئاشکرایە کە پرۆسەی نەچۆل گاز دایرێکشن یەک لەو پرۆسانێک کە زۆر گرنگن پرۆسەی با بڵێین نەچۆل گاز تریتمەنت یاخود نەچۆل گاز پرۆسەسینگ کە ئەمانجی سەرەکی ئەوەیە کە وەتەر ڤێپەر ریموڤ کا یاخود ریدیوس کاتێک لە نەچۆل گاز ستریمەکە. So it's very important to dehydrate the natural gas because it usually contains considerable amount of water vapors. As I mentioned earlier, the free water can be removed by using separators, and we already covered this topic. For example, we explained the 2 and 3 phase separator, vertical, horizontal separator, and spherical separator as well. So all these separators are used to remove the free water. For the water vapor, we have to adopt some techniques to remove water vapor from natural gas stream. As I mentioned earlier in many lectures, even at the beginning of this course, that the water vapor should be removed because it causes several technical problems. For example, corrosion, hydride, and we talk about hydride in a specific chapter, and reduce the heating value of the natural gas well. So there's many reasons that encourage me to remove the water vapor from the natural gas stream. Water vapors exist in the natural gas because the natural gas or the hydrocarbons exist. Firstly, exist in the underground reservoir, so under certain pressure and temperature, thus it may contain some amount of the water vapor. So I present the lecture PDF with you. Present. So share. Yeah. So here this is the lecture PDF or the lecture sheets. So the chapter title is the glycol dehydration or natural gas dehydration. So first of all, we talked about the general introduction about natural gas, raw natural gas, and dehydration process. Then we explained the. By the way, as I mentioned earlier, there's several processes that can be adopted to remove the water vapor. For example, we have adsorption process, we have absorption process. Adsorption process, we already explained it, okay? So it consists of a tower like that, and the process they call physical adsorption that can be occur inside the column. So the weight gas or the gas that loaded with the water vapor will be processed in this column, and there's components can be adopted to remove or to absorb the water vapor. For example, alumina, for example, silica gel, and other components. And we already explained that at the class. All right. We also talked about the absorption, okay? And we say there's several chemicals can be adapted or used in this process to absorb the water vapor from natural gas stream. For example, we have glycol. These chemicals, they say it has natural affinity toward the water vapor, so it can naturally absorb the water vapor from the natural gas stream, which is loaded with the considerable amount or some amounts of the water vapor. We also talk about these tables, shows or illustrates several physical properties of the glycol types, for example, ethylene glycol and diethylene glycol, and so on. We already explained that. We also explain the process. Okay, I'll also in today's lecture explain it or revise it. Okay, there's many units in the process. For example, we have the absorber tower, the regenerator tower. We have a flash separator, heat exchanger, pump as well. Okay, and here we can find all these, find all the definitions, and you can find description of these units. And as I remember, I explained all of them at the lecture. Anyway, I'll repeat it today here. Let's see, let's share this PPT. Present. All right. All right. So let's see. Well, here, as you can see, this is the process of natural gas dehydration process by using glycol. So here we have absorber tower. Here we have the setup or the originator tower. So this is the heart of our process. Here the gas will be dehydrated and dried. So there's two main types of the absorber tower, as you know, and I'm sure you already studied that before. For example, we have point column and trace columns. Here we use trace column, okay? So the weight gas will be processed here from this point, okay, and go through this column and through these trace. Okay? And the amine, sorry, just a minute.